Okay, class, welcome to another day of science class. Today we are starting our unit with force and motion. Today we're going to do a lab called measuring speed. And for this activity, we're going to review some of the things we've learned in the past with variables, but we also going to learn something new today with speed. So let me go over some ideas that I want us to know. First of all, in the United States, we calculate speed by saying miles per hour. Okay, that's how we calculate speed. In other countries, speed is calculated by saying kilometers per hour. Speed, for scientists, is calculated by saying meters per second. Okay, so what we're going to do, I want you to understand that you see I have the word per here, P-E-R. This P, this capital P means per, which also means divided by. Okay. So you can see that we actually have a division sign there, right? The line there means divided by, means per. So this is read miles per hour. This is read kilometers per hour. And this is read meters per second, okay? So today what we're going to do, we're going to talk about how to calculate speed. Now, if, for instance, if you were in a car and you're speeding, sometimes... Well, I'm not going to say that about myself speeding. But anyway, how does a police officer know you're speeding? What tool do they have in order to determine whether or not you're speeding? They have something that we call a radar gun or a speedometer, right? So they can calculate your speed at any moment in time. Well, today we're going to use that same principle to calculate speed, okay? So speed, once again, is measured in distance over time. Distance over time. Now, so the first thing is I have some examples of how to calculate speed, or some examples for speed. And let's see whether or not you're able to find the answers for these. So if a car travels 100 miles in 2 hours, what is its speed? Well, we know that speed is measured distance over time. So the car is going to travel 100 miles, that's our distance, in 2 hours. So we know that 100 divided by 2 is 50 miles per hour. Is that correct? So our answer can be, it can be written two ways. It can be written by 50 miles per hour or 50 miles per hour. Okay? Example number 2. A car travels 30 kilometers in a half an hour. Well, the speed, once again, is distance over time. In this case, it would be kilometers over hour. So 30 kilometers over a half an hour. 30 kilometers times 2 divided by 1. Now, why do they do that? Because we have a half an hour here. So I have to flip my half an hour, right? You know that in your math class. When you divide like that, you have to flip that, right? So this 1/2 becomes 2 over 1 hour, right? So 30 times 2 is 60 kilometers over hour. This problem is a little bit more complicated, so I wanted to go over that one for you, okay? Now, so let's get to our activity today. You know our helper. Let's say hi to our helper today. Can you say hi, James?
Hi.
All right, okay, good. So today we're going to do, I'm going to read the experiment the way I usually do, and James is going to be the one carrying it out. And my helper, DJ, is going to help us by doing some writing today. Okay, so, ready, James? I'm going to read the activity. It says use the meter stick. We're going to use the small meter stick. We're not going to have masking tape. We don't need that today. But it said basically what's going to happen. It says in your tiny notebook, make a table like the one above. So right here, DJ, can you get this table for us right here? Table right here. All right. This table is what we're going to fill out first. We have 2 parts of the lab, part A and part B. So part A, we are simply trying to figure out what is the speed when... I'm over here. Okay. On the show right here. Okay, what is the speed if the car travels 50 centimeters? Now, we already said that in science, we use meters per second, right? But for our class, for this experiment, we're going to use centimeters per second. Okay, that's not the standard, but for our class, it will be because we obviously can't go 50 meters, okay? Okay, class, now we're going to... record get our data, and James is going to release the cart from notch A, and then when he releases it, he's not going to start the timer until it reaches the meter stick, which is 50 centimeters in length. So he's going to stop it. He's going to start it at when when it reaches the meter stick, and then he's going to end it when it reaches the end of the meter stick. Okay, so here we go. James, when you're ready.
Okay, ready, set, go. 0.54 seconds.
What was the time again?
0.54 seconds.
Okay.
Okay. Ready, set, go. We're gonna stop. Okay. Ready, set, go. 0.43 seconds.
You sure that, DJ?
Ready, set, go. 0.48 seconds.
Okay. Okay, class. So now that we have our times, you should now be able to calculate the speed. And all you have to do, class, to calculate speed is take the distance, which was the same each time, right? Distance divided by time, and we will be able to calculate our speed. Now, we did 3 trials. Why do we do more than 1 trial? Because we want to make sure our results are accurate. In a real study, obviously 3 would not be good enough, but for our purposes, it is. So now, class, for part B, what we're going to do, make this very clear, for part B, we are now concerned about the release height. So we're adding variables into our experiment now. So James, if you wouldn't mind standing aside here, I'm going to show them what I mean by variables. And you should know about variables because we have talked about these in class already. So a constant variable is a controlled variable. It is what is kept the same. So typically when we talk about the controlled variables, we typically are referring to the materials, not all the time, but in this case, we definitely will be talking about what materials were kept the same each time we did the experiment. And then the tested variable, or the manipulated variable is also called, or the independent variable. So tested, manipulated, and independent variable is what is intentionally changed to determine effect. So we are intentionally changing something. So it should be very clear what we're changing. When I say, if we change the release height, what is that going to affect? And so when I mean release height, I'm talking about notch, see DJ here, notch A, notch B, I'm sorry, I messed up. Notch A, notch B, and notch C. So these are our different release heights. What is that going to affect? How will that affect the speed? And then the last variable is our responding variable, or the dependent variable, the possible effect of the manipulated variable. Okay, so I'm not going to go over that with you because we have done several labs this year already that will hopefully know and should be able to identify the statement of problem. You should be able to write that, the hypothesis and if-then statement, and also the variables, which are continued here. Okay, now we're going to talk about the second part of our experiment, part B, which we are talking about the release height. How does the release height affect the speed? Okay, so James, come on over here, James. Jamia, you're gonna do your writing again. So James, you're gonna now start from the beginning, James. From A, he's gonna start from A again. And he's gonna release it. And once again, he's not gonna start timing until he gets to the beginning of a meter set and then to the end. Okay.
.66. .51. 0.68.
Okay, so that was for notch A class, notch A. Okay, now we're going to do the same thing for notch B. Notch B, okay?
1.76. One, 8.
We're slowing down, everybody. Slowing down.
0.84.
Okay, now finally for part C. We're going to do part C. I'm sorry, not C, not part C.
One point two.
I'm trying to get you do it right.
1.33. 1.38.
Okay, class. So now we have all of our data. Okay. So it's now up to you to calculate the speed. And you should be able to do that because all you're doing is taking your distance divided by time. Use your calculator on your iPad to do that, or you can use a real calculator, of course. And then, of course, you should know how to fill out the materials procedure. Remember, procedures are written in commands. All right, class. Let's say hi to our helpers today. Let me have the camera now. And we have some helpers. Come over here, helpers. Come over here, helpers. We have 3 lovely helpers today. Don't move, helper. Yeah, my 3 children. We have in order of age. We have Jamia, who is 19. DJ is 18. And James is 15. These are my kids. Thank you, helpers. Say, can you guys wave? Say something. What are you gonna do?
What up?
Okay. Okay. All
I'm
right.
outta
Thank
here.
you guys. Wait a minute. You gotta put it back on me. I always gotta do my famous.
Okay, this.
Okay, class. We'll see you in class. Bye bye.